Now, the next thing I'm going to work on is the top, but before we do that, take a look over here. We've got some sharp edges. I was just a little bit cautious here. I didn't want my roundover to go into the point where it meets that dado. So I was very careful to just kind of keep those sharp. We'll just round them over to match and do that all the way around just to get these shells looking nice and smooth. All right, now let's carefully get this guy on the ground, and we'll talk a little bit about the structure and why it's kind of fragile at this point. Well, because we only have one apron, the one at the back here that stretches all the way between these legs, we don't have as much sturdiness in this base as we might normally have. So it's kind of a unique design in that way, and maybe even a little bit risky of a design. But what I'm going to do is put a top on here. It's going to be a substantial top, a little bit thicker than usual, and then I haven't figured out exactly what I'm going to do, but we'll anchor the top to the base very securely, but still allowing for wood movement. And then that top will actually be an important part of the overall structure of this desk and preventing this sort of little bit of motion that we have here, right? So for now, we have to be a little bit careful with this piece. You don't want to sit on it or anything like that. We're going to put it aside and start to focus on our top. But it won't be until this thing marries with the top that we actually have a nice sturdy desk. So let's get to the top. So the top is going to be made from walnut, and there's really kind of two schools of thought when it comes to buying walnut. One is to try to get everything to be that perfect brown color, nice and even color, also the same grain in each board. That's really difficult to do, especially with thinner boards. Most of the good stuff is going to be made into veneer, right? So what we're left with when we have a lot of these, 4/4, 5/4 pieces is stuff with a lot of sapwood. You got a lot of swirly, twirly kind of grain, maybe not the most consistent material. So the second school of thought when buying walnut is to embrace the chaos, and that's the one I recommend. Makes it a lot easier when you're buying your boards because you could just say, is it straight? Is it not cupped? If that's the case, cool, I'll buy it. And then ultimately, when you have these, wild grain patterns, some knots and some sapwood, it looks a little bit more natural. And what is a natural product? If you want something that looks perfectly consistent, go buy something made of glass or metal or plastic, right? So I have really come around to embracing the chaos, especially when it comes to walnut. Let the wood be wood, and it's gonna look awesome. The other thing I wanna mention is the thickness. Now, I like to buy my tabletop material thicker than 4/4. 4/4, by the time I mill it down, especially if it's a long tabletop, I'm gonna be probably 3/4 of an inch or less. And I don't want that for a tabletop. I like a substantial thickness. So I'm gonna start typically with 5/4 or 6/4 if it's a really big table. And then by the time I do all of my milling, I'm left with a pretty substantial thickness that looks better and it's more sturdy, and it just shows that this is a custom piece of furniture. So let's get to making this top. I'm basically gonna lay everything out to what I think looks good, and then we'll start cutting the pieces down. I've got enough width here to account for cleanup and edge jointing, so I'll start by chopping to rough length. And I nearly always chop off a few inches at each end to get rid of any cracks or checks. Boards of this length can take a lot of passes to joint flat, which is why I like starting with thicker stock. And the final thickness is whatever it is. When all the boards are clean and flat, I'm done. After the first round of cleanup, I'm still a little bit oversized in width, which is good, because I still need to joint the glue edges. I like to have the joiner set for a very light cut when prepping the edge for a glue up. With the boards in the order that I think looks good, I label them, and then get ready to put in the dominoes. Now I'm only using dominoes here to help keep these panels aligned. Last time we used cauls, and we could do that here too if we had really long ones, but on large panels like this I find dominoes or biscuits to be a really good solution. Notice that I don't even bother using glue on the tenons because this isn't about strength. Finally, I clamp the shit out of it. Now while this glue is drying, it's a good time to get a little bit of epoxy and fill any of these knot holes or areas that I just want to drip some epoxy into. Unfortunately, some of the holes go all the way through. So if I just pour epoxy in here, a couple hours later I may come back to an empty hole and a puddle of epoxy. So let's go ahead and lift this thing up and see if any of these knots transfer through to the other side. Oh, it's heavy. And it looks like we only have two. These two guys right here. Okay, so we'll mix up a little bit of epoxy here. I happen to be using Total Boat, but West Systems in the pumps like this is pretty good too. Now we could use this stuff just clear, but I think it actually looks a lot better if it's got a brown color to it. So a couple of drops of trans tint, dye concentrate. Honestly, one drop would have been enough, but it gave me two, so we have two. Ideally, I want it to kind of have a heaping look to it. I'll come back in a few seconds. It'll probably sink down a little bit, but I don't want it to be below the surface. So the glue is definitely dry, the epoxy is dry. I flipped this guy over. I'm going to start working on the bottom. And what's interesting is the places I taped off, those look fine, but I've got a couple spots that came up where they were just small knots that I filled, and those little tiny knots went all the way through, hence this little drip mark here. So I always find that interesting. So I'm just going to hit this with low grit sandpaper just to clean it up. So now that I have a clean surface to play with, I'm going to square up the ends. I do want to put curvature there, but I want to make sure we have a nice clean square end so I can measure back for that curve. Now once we've sanded the show side, we could start to think about our curves on the ends. It's going to be pretty much the same thing that we did on the shelves. We're going to go a ½ inch in on each side and then make a curve to the center point. Now, I don't know what I was thinking this morning. I just maybe didn't have enough coffee. I started to go down this path of using a jigsaw to make the cut, and then I was going to sand it nice and smooth. The problem is you're dealing with end grain here. It's going to take a long time. I mean, you could use files, rasps, you could use a belt sander to get that shape, certainly even hand tools. You could use hand planes to do that, but end grain is notoriously difficult. This is absolutely a time to use a flush trim bit and a template. So what I did was I took that same curve, I put it into a piece of MDF like this, and I'm going to use this, since I've already done the jigsawing to get the rough shape, I could use this to do the final cleanup, and the results are going to be a whole lot better. So here's the flush trim bit that I'm using. It's one of those newer ones, compression bit style, and I've got the bearing at the top. Probably have to do this in 2 passes. If you're going to invest some money in good router bits, one of the best places to do that is with your flush trim bits. The quality and orientation of the cutters can make a night and day difference in the results that you get. Now the next thing I'm going to do is add an edge profile. You can always keep your edges square, especially for a tabletop. I mean, if that's the look that you like. I like to lighten the look, especially when I have a thicker top like this. Kind of gives it just a lighter appearance, and also, I don't know, when I sit at a desk that has a really cool, well thought out profile to it, I can't help but touch it. Maybe that's a bad thing. But ultimately, I'm just going to put a 45-degree chamfer all the way around the bottom, and then we'll soften the top edge with a roundover. we're going to secure the top to the base with cleats. I'll cut them with miters on both ends, and they'll fit right inside our aprons. Each cleat gets 2 screw holes. Once drilled, I ream the hole so that it allows the screw to move front to back, and that's going to accommodate some movement. The cleats are then dressed up and glued in place. Even though few people will ever see these, it's nice to make them look good. So now I've got the top upside down. On the workbench, I'm actually going to take the base and put that on top of here. The base is pretty light, so not too bad. Now, I am a little bit concerned if I just drive my screws straight through here without pre-drilling into the walnut. Never a great idea, you know, just to avoid splitting. So I'm going to take the drill bit that I used to make the pilot hole here, keep it nice and centered, and just tap. I want to mark screw locations, or where the location will be, and then I'll be able to pre-drill after removing our base. And now I'll just pre-drill at each location. Got a piece of tape here to make sure I don't go too deep. So let's see if we can get this guy on its feet. Here we go. And my floor is exceptionally uneven. Concrete is in bad shape, so that wobble is to be expected. All right, so that's looking pretty good. Now, normally I would not attach a top to a base at this stage because we still have a drawer to make. But with this particular design, we do have to worry about the strength. We've got legs that are sweeping out this way. We're missing part of an apron here, so now the top is kind of substituting for that, giving us a little bit more strength. Everything's nice and rigid now, so I should be able to construct the drawer to fit inside that opening. So now it's time to get excited because we've got a challenge ahead of us. The desk itself so far was actually kind of the easy part. The drawer is the thing that I'm stressing out a little bit over because we've got some weird angles here. We've got some very precise fitting to do. And I've also got joinery where the sides poke through the drawer front through tenons, and that's a pretty high risk sort of proposition. So we'll see how that goes. I'm excited, apprehensive all at the same time. Fortunately, we already cut our drawer sides. We thought ahead with that. So we've got those bevels cut and the sides are just a little bit long. That's okay. And we have our drawer back. So the only thing missing is the drawer front. I am going with white oak as an accent to match what we've done with the shelves. And this piece of white oak in particular is just really, really cool looking. I've got some curl in here. So I've held on to this for a long time, waiting for that special project, and here we are. All right, so this curl, I think, is gonna really look good on the front, especially once it gets oiled up. So to cut this guy to length, we just need to measure the widest part of this opening, and then we'll cut the bevels. And again, that's that same 56 degrees. As for slides, you know, you might think this is kind of a shame not to use wooden slides on a project like this, but I have no problem on a functional piece of furniture using mechanical slides because in a lot of cases, they're just better. I don't care what anybody says. In this case, we've got an overhang, right? So if I just had wooden slides, it's really difficult to get to the back of the drawer. But a mechanical slide with over travel, or at the very least full extension, will allow me to get more access to the back and not have to worry about a drawer falling out, tipping, or anything weird like that. So when we build this drawer, we have to account for the fact that these are a 1/2 inch thick, which means there has to be a gap between the side and this opening here to allow this guy to fit in. But we'll tackle that later. Right now, let's just focus on making that drawer front. When you're making the drawer front, cut 1 or 2 extra pieces. As you'll see later, there's a high probability of making an error, so it's a good idea to have at least 1 spare. The drawer front gets our 56-degree miter on both ends, and I sneak up on the perfect fit using a few shims and the drawer opening itself. All right, things are going to get kind of intense with this drawer. On our drawer fronts, you can see I've shaded in the areas where we will have 2 mortises, and our drawer sides will punch through with tenons, and those tenons will show through at the front. It's going to look very cool, and if this were like a nice square edge, this might be a little bit easier, but we actually have parallelograms here. So with a parallelogram, it's a little bit more difficult because you don't have square corners, right? They're all different angles, either more than 90 or less than 90. So we have to figure out a way to start off on the right foot to get good quality mortises in there. And then we can make our tenons match those mortises, hopefully. So the way that I always do this is by using strips of material to make some kind of a template. Now these are fairly small mortises, right? And most router bits are going to be probably a little bit too big for that. I honestly don't even know why I have this, or I'm going to have to look up the part number and see if I can get you guys the link, but it's a very small flush trim bit. And that will allow me to actually get as tight into those corners as possible so that all I have to do once I do the routing is a little bit of cleanup in the corners. Right? Easier said than done, but still, it stacks the cards in my favor that these walls are all going to be nice and clean and consistent. The goal here is to create a little template that we could drop right on top of here that engages with the end and locates these perfectly, so I can do this once on one side, flip it, and do it again on the other side, and then just use a chisel to fix the rest of the mortise. So there's a lot of details here. There's measurements. I'm going to, in the plans give you the numbers, but I think it's really the method that's the most important thing for me to convey. So I've got some 5/8 wide strips and some 1/2 inch wide strips, way more than I need, because I just want to make sure I have enough, and I'm going to make a template out of these. 2 5/8 inch strips are cut at 65 degrees, somewhere in the middle. Together, these pieces will go on either side of our mortises. With a 1/2 inch strip in the middle and 2 5/8 strips on the outside, you can see how the template will go together. Now cut 2 little 1/2 inch spacers at 56 degrees using one of the 1/2 inch strips. These are going to help us get the right mortise size during the glue up. And that's all the cuts that we need to make. Now it's all about systematically gluing this thing together. We'll glue 1/2 at a time. The long side is clamped together temporarily just to keep everything in place. With a 56-degree piece of scrap in place as a guide, glue in the mitered strips and push them right up against that mitered edge. It's imperative that these pieces create a parallel mortise wall. Now add a clamp to the short side. Once the glue is dry, drop in the 1/2 inch spacers and add glue to the 5/8 strips on the long side. The strips are simply pushed over until the spacers make them stop. Add a clamp and let it dry. Clean off all the glue and drop the template onto the drawer front. If it's not exactly the same width, try to trim it up on both sides, keeping those mortises centered. The template now needs some fences to help locate the mortises. I've already drawn the mortises on the drawer front, so I can simply use those to align the jig. The fence pieces are glued in place using some spring clamps. To make the jig work on both sides of the drawer front, we need to add another fence to the other face using the same process. Now you might be wondering if you could just cut these mortises by hand, and you absolutely can. At least in my hands though, when I cut something by hand, there's a little bit of variation between each one of the mortises. So I have 4 of these in total, right? The drawer front gets 1, 2, 3, and 4. So each one of them might be slightly different. So when it comes time to make the tenons that join into that drawer front, we may have to make each tenon match a specific mortise. Using a template like this, make sure that each one of these mortises is exactly the same so that each of the tenons can be exactly the same. And furthermore, when you have a through tenon, the most important surface is that outside surface. So if we have any flaws out here, when that tenon pokes through, it's going to be visible. It's not going to look very good. So for me, it's worth the extra effort and time to make something like this. And as ugly as it is, it's going to work pretty well to give us a good repeatable result. And that's what I'm after. All right, so next up, we got to actually make some of those mortises. I'm going to first lay out the location, and then we're going to drill through with a drill bit just to remove as much stock as possible. I'm kind of pushing the limits of the bit size that you want to use here. If you're not confident locating the bit, just use a smaller one. All right, so now we need to get prepared for rounding. The key is I want to make sure that this thing is indexed perfectly, locked in place, and then we can secure it to the workbench. So once I have a pretty good setting here, I'll use a spring clamp. That's pretty good. I can flip it over. I'm going to use a hold fast on the far end. And I've drawn a line here to show where my router base is going to go. That lets me know that I can use another clamp to clamp to the workbench and make it as secure as possible. All right, little chance that that is going to move at this point. And now we could bring our router in here. I've got my little laminate trimmer set up with that bit that I showed you before, just enough that the bearing is making contact with the template. So the approach here is to get that bit down into the hole. And then I'm going to very slowly, securely, and carefully kind of go into a slight clockwise direction, making these little baby circle motions. I just want to kind of kiss the edges as I work my way around until the bearing bottoms out and actually hits the extremities of the template. If you kind of just push it right into one of the walls, bad things can happen. I mean, this is white oak, so it's pretty dense stuff. All right, so we'll take our time, hope for the best. All right, well, this is really unfortunate. I really probably should have used my secondary pieces to confirm that everything was working before using my good work piece, because this one is now shot. Apparently what happened is some point during the routing operation, the bearings came off. So if you look at the bit, you've got this post here, the two bearings sit on top of that, and there's this little pin that goes, or what would you call that? Like a washer keeper thingy that goes here and holds those in place. Somehow that must have let go, whether it's vibration or what, I don't know. I actually have a second one of these bits, but you can see it's got that little piece on there. So when the bearings drop off, what happens? Well, now the bit is just free to go where it wants to go. So we have gone too far on this mortise, which means this workpiece is now shot. Unfortunately, this was the good one. This is the one with that curl, and it's at this stage not really worth my time or sanity to try to do a fix on this. So thankfully, I do have those other pieces, but these are very plain, kind of boring, but it's all I've got now. So we'll make do. The question though, is how much do I trust this stupid bit? You know what I mean? Like, I think what I can do is try it again, but I'm gonna have to stop much more frequently and double check and make sure everything is in place, because I don't trust it at this point. And if this fails again, my only other recourse is to just use a larger bit and get as much as I can. It's not going to be able to get very much because it won't get into those corners without the small diameter. So super disappointing. I don't lose my temper very often, but in this case, this is one of those times where I felt like I had enough precautions in place that I shouldn't have had a problem, but I did have a problem, and I destroyed my headphones. And now I only punish myself because now I got to go on Amazon and buy a new set of headphones. Anger and shop tools and electronics, they don't mix. All right, that is more like it. Exactly what I expected to see. So we have our flat edges, we still have rounded corners, but we're going to deal with that a little bit later. So I can move on to the second one now. And by the way, see, I added a couple of extra holes. I just went to the drill press and drilled into those open areas with an 1/8 inch bit. I figured just there's less material, it's less strain on the bit. Now, before I take this apart and route the other side, I want to make sure nothing moves, because I want to flip this thing over. And before we remove the template, we can actually save ourselves a lot of headache here by either using a knife to scribe all the way into the corners. That'll give us a nice guideline for our angles there where they meet. Or you can come in with a chisel and just go right up against the template side and give it a few taps. But the problem is this inside corner, right, that's less than 90 degrees. And while this is a nice sharp edge on here, the angle of that bevel edge is not steep enough. So when I bring this chisel in, I've got a little bit of a gap there, which means I can't get right into the corner without mangling part of the template or part of the mortise. So I'm gonna need to do a little grinding on a cheap chisel. And now I've got a much steeper angle. This chisel is still usable, but obviously it's a little bit mangled from freehand grinding. But I now can fit that up against the wall, into that corner, and get a nice sharp starting point here. Now each corner is already established, so when it comes time to clear out the excess, we can easily do that and maintain a nice crisp corner by making our final pass in that line. But before we get to that, we need to route the other side. All right, so now it's time for fun with chisels. So the idea here is we want to get right into those corners, so I'm real glad I got this mangled chisel to do the work. And you don't want to go right into that line, right? That's the last spot that you hit. So we want to remove as much material in front of that line as possible so that when we do go to the line, we don't push back. You see the shape of this bevel? If we push too hard, the wood grain can actually push the chisel back this way and deform our line. So we don't want that. So I'm just going to go in there across the grain and remove what I can. I'm only going about halfway deep, maybe a little bit more. We're going to flip this and work in from the other side. So you don't need to go all the way. But once I have that extra material removed, to go right on my line, right in the corner. Okay, that one looks pretty good. So I'll jump across to this guy. Now I'm going to put the template back on here as just a rough guide. You see, the back of these mortises, if this faces the inside of the drawer, they don't matter as much because there's going to be a work piece that will go, the drawer side will go and cover all of this with the shoulder. So if these look perfect on the front but flare out and open up a little bit in the back, that's okay. So I'm not as concerned about absolute perfection from back here, but it would be nice to use this jig as a, something to help with the chiseling. All right, that's looking pretty good. Nice and clean. The show face looks nice and crisp. The back side, if you want to, you could even bevel some of these edges just a little bit, ease them, so that makes it a little easier for the tendons to go in. But for now, this is about as far as we're gonna take it. And I gotta say, for a very inexpensive chisel, this thing did the entire chiseling operation. And while I did have to mangle the bevel, it stayed pretty sharp. So, can't beat a good bargain chisel.